software implementation behind our fun. Here, the art programming also plays a particular role behind our fun. In this lockdown, we are blessed to have the knowledge-oriented webinars and online interaction with scholars. I hope we will definitely gain the knowledge through this webinar. I wish a very all the best to each and every participant who are here. Thank you. Now I request Sri Varaprasad Sir, Principal in Charge, to give the presidential remarks on this occasion. Thank you.
Yes.
A very good morning to you all, learned participants of this UGC sponsored national workshop. On behalf of K.B.N College Autonomous, I extend a warm welcome to all the distinguished participants of this national webinar. As you all know, the present situation of COVID-19 pandemic, the educational institutions are also one of the most affected besides other areas. To overcome this, each and every sector is trying its best, putting efforts to balance the loss occurred. As a result, the teaching fraternity across the globe has come out with online teaching resources as a substitute to the learning system. One among such attempts is conducting webinars to enhance learning horizons. The University Grants Commission has been requesting the academic community to make productive use of the lockdown period in the wake of COVID-19 outbreak to ensure uninterrupted teaching and learning at home and minimize academic loss. The MHRD and UGC instructed the higher education institutions in the country to create awareness among the academic fraternity using the digital platforms by teachers, students, and researchers in universities and colleges. Further, the UGC has recommended certain ways of online learning process to be held and conducted from home. And one of the attempts and one of the efforts made by the Department of Mathematics and Statistics of our college is this national webinar. The UGC sponsored 6-day national webinar on discovering statistics using R. It starts from today, that is 15th June 2020 to 20th June 2020. I appreciate the Department of Mathematics and Statistics for coming forward to organize this 6-day national webinar. And on this occasion, in this webinar, the following topics are to be covered. Number 1, introduction to R, understanding data and its types, vectors and matrix operations, summary statistics and basic graphs, 3D data visualization, hypothesis testing T and chi-square tests, analysis of variance, simple correlation and regression, multiple linear regression, time series, and case studies. And we have a very good resource person, Dr. R. Vishnuvardhan, who is Assistant Professor in the Department of Statistics from Pondicherry University, Pondicherry. And I wish and I hope that it would be a very good learning experience to all the participants during this lockdown period. And I wish you all, with these few words, I would like to conclude my remarks, and I wish all the learners, all the participants, a very happy learning. Have a great day. Thank you.
There is a disturbance, sir. There is a break in the network.
There is a break in the network. Sir, audio వినిపించట్లేదని చాలా మంది
ఆడియో వస్తుంది.
విష్ణువర్ధన్ సార్ కనిపించడం
ఆయన
Hello.
Now I request the resource person, Vishnuvardhan sir, Department of Statistics, Pondicherry University, to take the lead.
Okay. So good morning to everyone. So first of all, thanks to, is my voice audible? Yeah, fine. So first of all, good morning to everyone. First of all, I should express my sincere thanks to the Department of Statistics of K.B.N College, particularly Radhika Madam, Venkateshwar sir, HOD, and Radhika Madam, and my good friend Vijay. And my gratitudes to the correspondent, the management of this K.B.N College for giving me this platform once again to stand before you after I think roughly 2.5 years or 3 years, because 3 years back I was in K.B.N for 3 days to conduct the training program on SPSS. But this time they have come with a big request to have a training, proper training in R for a period of time from 15th June to this 20th June. Okay, so I'll first share my screen so that we can go listening to the content matching with the slides so that you can have a better understanding, right? Right, fine. You're able to see the screen now? Fine. Okay. Now, generally, I won't put that picture on my slide, first slide, just to recollect my memories with the K.B.N College when I visited last time for a 3 days workshop on SPSS. So this was the pic I got from during the presentation at that time. So that was a very good memory for me. Okay, so actually the total contents what we have decided is purely for graduate and budding students who are taking their line of thinking to take higher education in terms of in statistical discipline. Okay, so we start with very basic introduction about R, what does it stands for, where we can download the R, and how to start working with R with the basic functions and objects, and then how to do some matrix operations, how to define a vector, because the disciplines of mathematics and statistics, even the computer science, most of the time we deal with vector-based data sets or matrix-based forms of information where we have to handle large amount of data sets. Clear? So with this thing, we start with introduction to R and understanding the data. How best we can understanding the data, what is the role of a statistician, and why in the present scenario, the data scientist or a data practitioner, particularly a statistician having better knowledge with computer programming, has gained a lot of attention to and to do most of the courses, and the data analytics field has emerged to a big platform, because this title is also relating to that only. So what we can discover out of the statistics, how to discover the statistical data using certain platform of software. It may be SPSS, it may be R, it may be Excel, it may be Minitab, and so on and so forth. There are a wide variety of statistical softwares available. But now this is quite easy to understand, and it is a freeware. Anyone can download, anyone can use to the best of their knowledge. And the main crux of this particular webinar is to make you aware and understand that what data speaks to us, what data is ready to tell to the practitioner, and what patterns it has, how it want to exhibit using the statistical methodologies. So it's a pure number game. It's a pure number game where we have to understand a lot that the numbers which we have in the data are very, very, very important to chisel out and to make out some beautiful meanings. And there is a simple and very important line that statisticians tries at most to make sense of the data. Okay, statisticians are ready are for that, to make out sense of the data, to give out a proper understanding for a better decision making. So with a gentle introduction, let me start the presentation mode that no. Okay, we'll start with our premise. This total, I repeat again, the total content of the presentations is prepared, is being delivered, keeping in mind that the graduate students are the most students that are to be benefitable. Okay, benefited, that are to be benefited. Okay, now, so the general question that comes to everyone's mind: how to start? How should I start with a new software, or how I can start with a new language which I wish to learn? For which there is a direct where if I wish to start the learning with for R, I can start directly. There is a dedicated website which is displayed here. That is the http://cran.org.org. Okay, so this CRAN is nothing but Comprehensive R Archive Network. It has bundles of packages. It has bundles and bundles of packages ranging from thousands to thousands of packages are available. Each package is utilized for its own purpose. Okay, we will come to know what packages are available, how to install a package, how to work with a package in this 6-day webinar. Okay, now, once you go to this website, you will have a latest R version. The current R version is 4.0.0. Okay, so now once we have this, there are different kinds of a OS, like if your laptop is of Windows, Mac, or different OS version. Accordingly, you can download the R, what we say, file, and then there is a button called download and install R. Once it is done, you will come to see an R icon. Okay, now double click on that, then you'll come to see the R console like this. You'll come to see the R console like this. So this is the first look of R. This is the first look of R. So here, to have a better view of the text, you can go to edit and then change the font size to 12, 14. That depends upon how best you want to present your results or your programming, all these things. Now, so this, what we call, is called prompt button. In our language, the prompt button is called what now? So it indicates us, the person who wish to program something in our console, it is indicating that what now I have to do. Is it 2 plus 4 I should do? Is it to run a t-test? Is it to build a model? Is it to build a graph, generate random numbers? Okay, build some advanced modeling, create 3D visualization. What next? What else? We can do wonders. Especially what and all which were not feasible with the different softwares. We were able to do all those things to the most extent with our language. Okay, so we should now next we go with this taking help in R. How to take help, because for a beginner I know a function called read.csv. What actually read.csv stands for? How to key in the how to key in the arguments within the function of read.csv. What actually CSV stands for? To know all these things, we can have a question mark, read.table, what is given as such here, or we can go with help.search within double quotation, read.csv. Okay, so whenever you are trying to take the help of any particular package or object or function, better it is mandatory to give double quotations and type the required object of a what we say this function. Okay, so this is how we go with the taking help in R, and R is very case sensitive, that we'll come to know how you define a variable name. Let us take, I'm defining RVV. If I take RVV as capital R, small v, and once I load the data into that particular temporary variable, thereafter I should call the total data in the same case sensitive manner. That is, I should type capital R, small v. If not, it says there is no variable RVV found. We couldn't find RVV. If I type small r, capital, any different part, it is a pure case sensitive scenario. Okay, now how to install a package? How to install a package, right? There is a function object called this install.packages. I want to install a package called tree. Okay, and I have used one more argument, that is what we call dependencies is equal to true. Dependencies is equal to true means what and all sub libraries available for tree, which are supporting libraries available for tree, that will come along with this package. Okay, if not, what will happen? What will happen is, when we start using this package at a certain particular point of time, it will say this package is not available, which are supportive enough to execute some other arguments or functions within the tree library. So what will happen is, it is a good practice that in order to install a package, you should give the package name within double quotation and make the good practice that dependencies is equal to true. All related supporting libraries do get installed along with the main package, what is called tree. Now, once the package is once this line is executed using control R or control enter, okay, is it control R or control enter? Now it will ask a mirror. Okay, which mirror you want to select? Means mirror is nothing but the area from where you want to download the particular thing. There are several countries names will be there. Okay, so there I may choose any but one particular country for the downloading that particular package, repositories of libraries. Then once we select the mirror, and click on OK, then automatically this kind of a thing will come, installing package, so on so, and then this kind of a message, package tree successfully unpacked and MD5 sums checked. So this is what we call successful installation of the package. Now, once the packages comes to a local library, then how to start working with R? The way to call the library, the way to call the package using library. Okay, library of tree. Once you call the library of tree, all the necessary functions, objects, formula, anything will get into activated, and it will be, all the functions can be ready for usage. Okay, now this is what we call install.package. This is very much to be noted, that install.packages tree dependencies is equal to true. And to call the particular package which is installed, which is already available, because once you install the package, there are some hundreds of packages that come along with the basic R version. Okay, library mass is one package which is widely used for matrix operations when you start doing this multiple matrix based models. Okay, that will help a lot. So like this is one thing. Now we start doing some sort of a basic computations, because R is not only meant for advanced data analysis, but also it is user friendly, works as a calculator, works for any kind of operating operations which are on mathematical based or logical based. So we start with preliminary, very basic things so that we can get accustomed to the R environment about the prompt button and how to make use of certain operations to execute the required format. Now, what I did here is I want to do 2 plus 6. I can do this in two different things, two different ways. The first way is 2 plus 6, just I can type, I will get only 8. But I have a series of small exercises. Like I want to see to even basic 10th class student can also use R because it helps to do all sorts of what we say this calculation based mathematics, all these things we can do. So if I want to do series of activities like 2 plus 6, 7 minus 2, 8 into 3. So this plus, minus, and this is for multiplication. Asterisk is for multiplication. So, and to execute the series of actions and in one stretch, it should be separated by semicolon, like 2 plus 6 semicolon, 7 minus 2 semicolon, and 8 into 3. After this, you can give enter, okay? You can give enter. Once you give enter, it will say only one object is available for this, 2 plus 6, 7 minus 2, 5, and 8 into 3, 22. So this is what we can do. So executing some set of activities, some set of calculations in a stretch, better it is used to semicolon. Now we take logarithmic functions, log of 1 or 2 by 22, division operator. This is my logarithmic value. To get back to the thing, now we can start with complex numbers. I'm defining. This is what we call defining operator. C equal to 8.2 minus 3i. I am storing, I am defining this or assigning 8.2 minus 3i, this complex notion into C. Now, hereafter, I can work I can use many objects or functions using this C because C has this complex number. Okay, complex thing. Now, once if you want to see what C has, the C, when we enter C and press enter, 8.2 minus 3i. Now, on this particular variable, assigned variable, I want to see the real values of the C. Real value, this is the complex value, this is the real value. So what happens here is RE is a function which takes the real number from the total assigned complex number. Okay, so here the real number is 8.2. Now we can check whether the information assigned to a particular variable is dot complex is a function to see whether it is complex number or not. Suppose if I have given 8.2 minus 3 log 10 or 3 log some another function, then is dot complex will not give us true, it will give us false. It's a logical operation here. As dot complex. So what we have is, if I have some real number, I want to define that as uh, a complex number, then is dot is to verify whether it is complex number or not. As dot complex is to define a complex number using a real number. As dot complex 4.1 generates the output that 4.1 plus 0i. We can give some other conditions also so that we can have the complex number value also. Now, some other basic, very basic operations, what we can do is floor 4.2. Floor 4.2 is nothing but the nearest point will get, I mean, if it is 4.5, it will go to 5, 4.4, it will come to 4. The nearest value, it will get another function to do the same activity is around 5.8. Now, another function is that short minute. These pop-ups are there. Okay, another thing is some basic arithmetic operations, what we can do. I want to see 10 into 3 minus 2. If you have multiple activities like this, better to use braces, brackets, and then start defining the numbers along with the arithmetic operations. So it will take 10 into 3 minus 2. First it will take the 10 into 3 into first phase, and then do minus 2 with that, that is 28. And thereafter it is 4 plus 3 minus 8 into 2. 4 plus 3 is 7. So it will take like this, that will become minus 9. Similarly, 8 to the power of 4. Cap is nothing but power. Okay, 8 power 4, 8 to the power of 4, and then divided by 3, log of 33. It is no base. Okay, and now we take exponent value is nothing but exp of 2.8 will give back this thing like this, log 10. This is the normal log function. Log to the base 10 is defined as log 10 of 33 is this value. Okay, now if we define exp of 1.51, then it will revert back the 33 value. Okay, so with this small introduction, we'll first understand what are the basic operators that are to be used, in before you start doing some sort of a relational or logical operations in this R environment. Now this is plus symbol, minus symbol, this is for multiplication, this is for division, this is for integer, and this is for modulo, and this is for power. Okay, this is greater than or equal to assigning. That means if a is greater than or equal to 35, then do something. This is for if and condition, when, while, for loop, for different kind of logical operators, logical functions or looping functions. These relational operators will support us to say that if age greater than or equal to 35 and gender equal to male, then do summary statistics of these variables. Like this, we can start defining the required queries, and then we can get we can produce the output based on that particular program or coding. Okay, and this is not equal to operation. This is assigning equals to. Okay, and then less than or equal to. Now this is not and or. Okay, this not function most of time we use for removing the missing values or removing some other blank spaces in the data. That comes in data wrangling. That is simple to say data cleaning. Okay, and this is what we call model formulae. That is it we use it to assign a set of independent variables on the right hand side and the dependent variable on the left hand side. And this particular model formulae is used, that is tilde. Tilde is used in most of the regression based frameworks, like starting with simple regression, multiple regression, logistic, and so on and so forth. Many other regression based models, there we make use of this model formulae, that is tilde operator. Now, in the basic versions of R, we started with less than or equal to. These assignments were there. Okay, so but now we can use directly is equal to. Now, dollar symbol is nothing but indexing. Indexing, that means I have stored a data set in particular, let us take VV, and there is a variable called age. I want to call that name, element name, I mean, name of that particular total data set. I can call VV $age. Means I'm calling the particular, indexing that particular age from the VV data set and take for further calculations, whatever we have coded. And this is to, or colon, is to create a sequence of numbers, create a sequence of letters. What I mean, we'll see that. Okay, now what and all we have seen here, we'll try to implement it and then understand how we can better make use of these logical operators with a simple framework of simple calculations. That is, now itself we have seen that this colon is to create a sequence, right? Now I am defining that sequence should be stored in a variable called x. Okay, now what will happen? 3 to 10. This is the meaning. How to read is, how to understand is, create a sequence of variables 3 to 10. We start with the basic and then we'll see how gems can be added in between. Okay, 3 to 10 means it will start with 3, 4, 5, 6, 7, 8, 9. Okay, you can see for understanding here a simple function I have used is 2 to 10 means 2, 3, 4, 5, 6, 7, 8, 9, 10. And a reverse sequence can also be generated. Give the largest number first, then use colon, and then give the smallest number, where it will generate the sequence in reverse order. Now we'll come back for this, that now here I want to use this logical relational operators, greater than symbol, x greater than 5. That means in the total sequence generated, x greater than 5, how many will satisfy the condition that really those numbers are greater than 5? Now 3, 4, 5, they're all false because 3 is background, a small if function will work, that if x greater than 5 result true, if not false. A simple if condition will work out at the background, that here first argument, first index starts with 3 greater than 5, no, so print false. 4 greater than 5, no, print false. 5 greater than 5, no, print false. 6 greater than 5, yes, successful, then you give true. Then 7 greater than 5, 8 greater than 5, 9 greater than 5, 10 greater than 5. All these sequences at every point of time, background, a small loop will get generated that take the index of the x and verify the condition x greater than 5. If it is true, then print true. If not, they take the another option of the if condition, that is false. Now we will understand in a simple one more manner that x less than or equal to 7. How many values of this sequence are less than or equal to 7? Okay, so 3 is less than or equal to 7, true. 4, 5, 6, 7. Now 8, 9, 10 are false. So this is what we call working with relational operators with the generating of sequence. The same kind of relational operators can also be used in large data sets. Or I don't mean large in data set. Okay, just now I have a couple of minutes, I have given a small example. Let us take another example of today's, we are all very well connected with social media, that in Facebook, Twitter, Instagram, everywhere. It down every click or every activity of us is recorded as a data. Okay, how many clicks, how many up thumbs we have given, how many down thumbs we have given, okay, how many heart symbols we have given, how many what we say K symbols we have, emojis we have given, all those things. Now, if they want to retrieve some information, that let us take the country India, okay, within that take the age group of 18 to 25, and let me see for this COVID particular issue, the label called COVID, then how many have given this emojis, likes, shares, how many have shared, all this information. That is nothing but at every step, I'm creating multiple filters, okay, using this relational operator that select country equal to India, select the region equal to so-and-so, gender equal to male, age equal to 18 to 25, and see how many shares are there, how many likes are there, how many dislikes are there, what sort of comments are there. Using that comments will create a word cloud, what not. We can do wonders with the data. So data in olden days are just numbers, nominal, true or false, yes or no, painful, moderate, severe, something like this. But in the present context, data is something different. Means our voice is a data. Now the total recording is going on. My voice is a data for next aspects that will create some more meaningful patterns that will turn into knowledge who will listen in a proper manner. The video, what we are taking, the images, what we are taking, converts into pixels. Using that pixels, we work out, that is what we call pattern recognition. Like this, statistics is everywhere. Data from different backgrounds will make the data practitioner to create a blissful environment using the statistical methodologies with the proper, meaningful thoughts and decisions. That is the beauty of statistics I want to add here. Now we'll move further, that any less than x less than, any is one function that any value x less than 4, then I have one value which is satisfying this condition, the true. I can give less than or equal to 9. There will be many true. Okay, any value x greater than 10, there are no values because I generated a sequence 3 to 10, that is false. So now any value x greater than or equal to 2. Now what is the difference between here and here? Here it is greater than or equal to. Equal to assignment is added. So there is a value 10 which satisfies this condition. It resulted to true. Okay, now quick review here. The 2 to 10 generates a sequence of 2 to 10. 10 to 2 generates a reverse sequence of 10 to 2. Now, how to create a sequence within a given range with some increments. For graduate students, most of you might have done in C programming that using I++ function. I++ is nothing but increment one value at a time and print I. I takes values 1 to 10. For I equal to 1 to 10, I++, print I. What it will tell? It will take condition I equal to 1, then next I++. It's called induction parameter. Okay. It's called induction parameter where it will take 1, 2, 3, 4, 5. Okay, similarly, if you take on the left-hand side or different functions of that particular increment, decrement operators, we can do. So here also we can do sequence is a function used to generate a series of values, a sequence of values ranging from starting value from 0.1 to the end point 1.8 with an increment of 0.2. So it has three arguments here, 0.1, 1.8, and 0.2. Now see, once I execute this line after pressing enter, it will start with 0.1 with an increment of 0.2, that is 0.3, then 0.5, and so on and so forth, ends with 1.7, and thereafter 0.19. I mean, if it adds 0.2, it will be beyond the sequence upper limit of upper range of upper value of this sequence, what is defined here. That's why it will stop here with 1.9. Okay, someone is telling. Now, sequence here is 0.11, 0.1 to 2.1 with an increment. Just I increased my upper limit, so it came. Now, see the difference here. Since the upper range was 1.8, okay, since the upper range was 1.8, and then it was not satisfying here, so it stopped with 1.7. But now the range I made it as 2.1, so that 1.7, 1.9, 2.1, okay, all these things will get generated. Now I want to have a decremental sequence. I want to have a decremental sequence that 10 to 1 with a decrement of -1. That is 10, 9, 8, 7, 9. So here if you see 10 to 2 is also a decremental sequence with by default an decrement of by 1. Here we can change the decrement order. Okay, if I have 100 to 25 with a decrement of 5, then automatically it will generate 100, 95, 90, 85, something like this. Now, here if you see, another way to use a sequence is sequence from 1.2 by 0.2 length of 6. How many times? Means I'm not defining the upper range here as I did here. I am instructing that from 1.2 start generating the sequence with an increment of 0.2. How many times? With the length of the string, length of the sequence as 6. So if I make it 10, what will happen? 1.2, 0.4, 1.4, 1.6, 1.8, 2, 2.2, 2.4, 2.6, and like this it will get generated. So the length is nothing but how long your sequence should be. So there is no upper limit, but you're restricting the sequence of range, I mean, structure, length of the sequence using this length function. Okay, fine. Is there anything that many messages are coming? I don't know. Okay, fine. Thank you. Now, if you see this, and next thing is to generate a sequence. To generate a sequence, here if you see here, 2, 3, 5, 3, 4. What actually it is? So it generates a sequence in such a way that generate first two numbers, that is 1, 2. Generate next one, three numbers, that is 1, 2, 3. Generate five numbers, 1, 2, 3, 4, 5. Generate 3, 1, 2, 3. Generate 4, 1, 2, 3. That means creating sequences of multiple or different orders in one particular sequence. So here we have noticed one more definition, that is called C of. C of is nothing but creating a sequence of numerical values in one frame. That is what we call a vector. To define a vector, we use C of 2, 3. Generally, sequence of 2 is it will generate 1, 2. But I want multiple sequences whose length is different, like 2, 3, 6, 9, something like this. So the C of 2, 3, 5, 3, 4 will generate 1 to 2, 1 to 3, 1 to 3, 4, 5, 1 to 3, 1 to 3, 4. Okay. Hope I make it very clear here. Right. If any doubts are there, we'll take at the end of this morning session. Okay. Right. Now we'll go with some more definitions. That is what we call how to repeat a number. I already said that we start with a very basic so that we can understand, we can get used to the R environment. We at a later stage, how to define a vector with a string, how to define a vector with a numerical integers. Okay, all these things will get habituated and easily we can do with inferential statistics, descriptive summaries, data visualization. In many aspects, all these things will get helped us. All these things will get help to us. Okay. Now, REP is nothing but replicate 6. How many times? 3 times. The first argument is the number to be repeated, and the second argument is how many times it has to be repeated. Now here, now we are very clear that 2 to 6 is the argument which generates the sequence from 2 to 6. Okay, and generate each number how many times? Each equal to 3. That is 2, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 5, 6, 6, 6. Okay, now another way to do is if we give, what is the difference between this and this? If we give each equal to 3 means whatever the sequence generated, that will generate the sequence that each number of the sequence will repeat 3 times. But here, if I won't use the function each equal to 3, just use a function 3, then the sequence of 2 to 6 repeats 3 times. 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6. This is the basic difference between using each function and just using a number. Okay, so now a small difference we have to notice for this function and this function is here a single number is repeated 3 times, but here a sequence of numbers are repeated 3 times. Okay, now clubbing these two, we can do one more thing. Repeat 2 to 6, each number of the sequence 3 times. How many times? 2 times I have to repeat. That is nothing but this entire sequence will get repeated twice. You see, 2, 2, 2, 3, 3, 3. This here it is ended. This is one replication. But we have instructed to make it into two replications. That is time equal to 3. So thereafter it started with 2, 2, 2, 3, 3, 3, 4, 4, 4, 5, 6, 6. So this is one basic thing where sometimes it requires to generate in matrix operations or vector generation, or creating some dummy data set where we can define factor labels, all these things. Now, we will move little ahead. We will move little ahead. Now we'll use a function called update called GL. Okay, GL is nothing but generating levels. Generate GL 5 comma 2. 5 is nothing but sequence of 1 to 5. Each level each factor should be generated with 2 levels. The next argument after post comma is called how many levels to be generated. If you recapture the design of experiments, there we come across each level, each factor at a different levels. Sorry, someone is prompting me. Okay, sorry for that. Okay, now if you see this, yeah, 1 is repeated 2 times, 3, and so on. Here it is mentioning levels 5, 1, 2, 3, 4, 5. Now, using this particular generating levels function, we'll try to create a small data. Okay. Now, I'm using one variable here and defining it as an area. I'm using this GL. What is the first function? Levels. Second function is number of times each level should be repeated and how many times it should be done. This should be balanced accordingly. The number 28 should be taken in a proper way. Okay, so to have a balance. If not, it will have an imbalance in the area. Now, what labels that each factor has to be given? I'm giving 3 labels here. I already said C is a function to define a series of values, including, it may include numbers or it may include the strings as well. It may include strings as well. Now, here what I did is to make you aware how many parentheses we started. GL open parenthesis and C of one more parenthesis, and here we have closed one parenthesis, but we are left out with 1. But unknowingly, what happened? I started pressing enter. I pressed the key enter button. So immediately it said plus. It took plus. I mean, it will display plus. So then it indicates that function, the definition is not ended. So we have to check the proper parentheses and proper definitions so that we can clearly close the function with proper braces. Then I define closing parentheses, then it executed. Okay, then gender is GL, 2 genders, each of 3 level, what do you say? This is what, 3 times. Okay, and how many? 28. So this number should be equal to create a data frame here. Now, what are the labels here? Male and female. All the strings should be defined within double quotation, and numerical values, as we have seen here, there is no need of quotations within double quotation. Only string value should be defined in terms of a double quotation. Now, data.frame is one important function to be noted, that we can create the generated variables, that is area and gender into one particular data structure, that is a frame, data frame. Okay, so area comma data dot frame, area comma gender. If you have created age between so and so, then you can create age or comma age also. So this will display here. The first is the indexing, 1 to 28 actually, but I have displayed only 1 to 12, but just to know you, to make you understand, that's it. So area is the column. Now what we have given generating levels is 3 levels we have to generate. What are the levels? Rural, semi-urban, urban. Each level of this should be repeated 2 times. Okay, levels of 2 times. This is rural, rural, semi-urban, semi-urban, urban, urban. Again rural, rural, semi-urban, semi-urban, urban, urban. Now, here, once this is satisfied, next thing is gender. It has 2 factors, 3 levels. I mean, 3 times it is to be done. That is male, 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 female, 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 like this. So it repeats till the number is satisfied. Okay, so this is what we generate, what we can do with generating the things. Now we'll go into some numerical quantification, that how to define a vector and how to start computing the summary values out of the data. Okay, now see, this is hemoglobin level. I have it around 10 to 15 samples. Okay, now I'm defining how to define a variable just with a single variable instead of a data structure in Excel, text table, whatever you have. Okay, if I have a single string of values, a sequence of values here, then I can define separated, I can define these hemoglobin levels separated by comma. So C of 8.1, 10.2, and so on and so forth, 8.6 will get stored in hemoglobin level. Now, once I press this HB, see here also, just remind again, it is very case sensitive. You should call, once it is defined as capital H small b, thereafter you have to call in the same manner of the definition. Okay. Now, H 8.1, this is the sequence what it is stored here. Now, what is the class of HB? It is a numeric class. Okay. Now, mean, in first slides we have seen, to do a set of activities at a time, we have to separate the each function, mean, median, everything with a semicolon. But here, with the fastness, I committed a mistake that I used a comma. What it said? Unexpected comma in range HB. So only mean and median are computed and displayed, but not range and thereafter. Okay, so be careful in using multiple sequence of activities, but it should be separated by semicolon. Once I corrected this, then mean, H, median, range, variance. Where is a function called variance? This is the range which will display the minimum and maximum, smallest and largest. And this is the median of the data, and this is the mean of the data. Okay, so mean is 10.8, median is 11.1, which are very close. Okay, that's a good indication. 8.1 is the smallest value and 13.2 is the largest value, and the variance of the total data is 3.435. What about standard deviation? SD of HB, that's it. Or you can do manually computation, square root of variance. So SQRT of variance, where of HB is your standard deviation. Okay. Now summary of HB. Minimum. Summary is one object, one thing, one function that minimum, it will display around 6 to 7 statistical measures, that minimum, median, mean, third quartile, first quartile, and maximum. So instead of taking separate arguments here, functions here, use summary in total, which will display the minimum, the maximum, the mean, the median. Along with it, it will give the first quartile and the third quartile. And if you want particularly only the quantiles of the data, first, third quartile, median, median, and then third quartile, and 0th first quantile and 100th quantile, just use quantile of HB, it will display. Okay. Now, right, this is sorting. Sorting means by default it will be in ascending order. To descending order, reverse of sort of B, you can do with this. And here I may add one more. I'll be able to add some more arguments to have some more filtering. That reverse sort with indexing 2 to 5. With indexing 2 to 5. Say reverse sort and print only 2 to 5. 2 to 5 is nothing but this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now we are giving instruction that reverse sort and display only 2 to 5. So 2, 3, 4, 5. Those are displayed. Now sort of HB 2 to 5. So 2, 3, 4, 5. This 2 to 5 indicates the index value assigned to each numerical value here. Okay. Now this is how to, now we move with how to define matrix operations. Okay. Here I am defining a sequence of numbers 1 to 24 and storing in M. The dimension of M I am defining with a vector in a vector form, that is 3 rows, 4 columns with 2 different matrices. Okay, so 3 rows, 4 columns with the 2 different matrices. Arrange these 1 to 24 with the 3 rows, 4 columns, and 2 times. I can change this, that 3 rows, 2 columns, 4 times. This is what I get. Okay, this is for a dummy practice. But actually, when you have a matrix, then how to do that? So a matrix, define a matrix using an object called matrix. I already said a vector of values should be defined in vector, C, using C, and comma, number of rows. N row is nothing but number of rows is equal to 3. Okay, so 146, 258, 793, it will get displayed in column wise. So 146, number of rows is 3. Okay, now attributes of, this is what we call defining a matrix in a basic way. What is to be used? Matrix of C of the set of elements of matrix what you have, and number of rows is equal to 3. When you define this number of rows is equal to 3, these values will get split in column wise, 146, 258, 793. But if you want the sequence of values in row wise, that means you want to see 146 in first row, 256 in second row, 793 in third row, then matrix of C of the same values you take, but you need to add one more argument called by row equal to true. So this argument will enable that the C sequence of values which are given in this vector type will be defined 146. Number of rows is equal to 3. So dimension is 3. After that 245, 258 will go in second row. After that 793 will go in third. Fine. So once we define, thereafter we start doing some matrix calculations. Okay. So the simple technique where we have a lot of fun in graduation, even now, sometimes what to do, let us transpose the matrix. I want to see the transpose of the matrix, that is T of B. T is nothing but transpose. This is what we got. So 146 is 146, 258 is 258, 793 is 793. Fine, this is very trivial. But now we'll see how to define the row names and column names from some other calculations what we can do. So there are 2 different ways to define the row names. Either first we can define them into a temporary variable, defining A1, A2, A3 within double quotation, and then assigning row names. Row names is one particular thing we have to use to assign the row names to the matrix A. Okay, so here I have taken for understanding in 2 steps. First, I have defined the row names into one particular temporary variable, and I have taken the temporary variable to assign the row names of this matrix A using row names function. Okay, but directly what you can do is you can make it into one step, that is row names of A is equal to C of A1, A2, A3. That's it. Once we do that, A will take A1, A2, A3. Similarly, to have a column names, what we have to do? We have to use col names A is equal to C of B1, B2, B3. Okay, so this is the total matrix with all row headings and column headings. Okay, so what we have learned? First, we have learned how to define a matrix, and then now we are learning, we have understood that how to define row names and column names. Hereafter, what we have to do is, let me see the row sums. Let me take the column sums. So there is a simple thing that row sums, S is capital. Be careful in using this. Here row names and column names are on small case, lower case. But here row sums are S is capital. Okay. So row sums of A, it will give 10, 18, 17. Column sums, this is 11, 15, 19. What about row means? Row means is nothing but you have to use row, M is capital, row means of A, comma. I already said that multiple activities separate by semicolon. So row means, column means is this. Row mean is nothing but this is 3.33, this is 6, and this is 6.33. Column means is this is 3.665 and 6.33. So this is how you can do multiple calculations. Once you define a matrix, I can take a diagonal element of the matrix. I will see that. I can define the row names and column names. I can calculate the row sums, column sums. Okay, I can generate the row means and column means. Now, what about matrix multiplication? So general multiplication, I mean, multiplying two values, okay, is usually with only asterisk. But to compute, to have a matrix multiplication, we have to use a percentage, asterisk, percentage. Okay, now this is A and this is B. In the previous slide, we have seen the B vector, B matrix. So A and B results to this. Okay, with a blink of an eye, with a blink of a, generally when we are doing graduation or even after thereafter, when you want to do the matrix multiplication of 3 cross 3, 2 cross 2, very simple, in a very jovial way, we use it to, very happy for us. But when you want to do larger dimension, then starts its trickiness. So now with the software support, it is a blink of an eye that we will get the result. Even inverse of a matrix, see, with just one particular function called solve of A will give us the inverse of the matrix A. Just see, 3 cross 3, we use it to take minor, major, det of A, all these things. So that manual computation, the cumbersome in manual computation has been overcome with all this software support. So here I wish to add, without computer programming, this logical reasoning, all these things. So computers are indispensable partners to us for all mathematicians and statisticians. That without computers, in the present scenario of data world, we will not be able to doing wonders with by handling large sets of data sets, building models with a blink of an eye, and so many iterations, simulations, okay, bootstrapping, many huge techniques are being done with a blink of an eye. So that's why, to claim as a data scientist, I will add one line here, because we are able to see the beautifulness of the computer programming behind the math and statistical methods. Okay, means that without computers, so to claim as a data scientist, you should be having good knowledge, good amount of knowledge with math background, statistical methods, and a blend of programming also. Then only we can aim at, from the graduate to the post graduation, and thereafter you can aim to become a data scientist in this period of time. Okay, now let us see. I want to verify whether the obtained inverse is correct or not. Generally, this question does. In Excel, we do m function to multiply two matrices, m inverse to obtain the inverse of a matrix, whatever way the dimension, I mean square dimension. I mean 3 cross 3, 5 cross 5, 7 cross 7, whatever it is. Now, again, I want to verify whether the obtained inverse of matrix A is correct or not to see. Okay, what should we get? Inverse of A into A inverse is equal to identity matrix. This is what we have. So A is this matrix, A inverse here it is. So A into A inverse, that is solve of A, should result identity matrix. It has many decimals to go. Now, to have a proper identity matrix without decimals, just use a function called round. Round of this, again repeat this, we'll get proper identity matrix, that is 1 1 1 0 0 0 0 1. Now I want to see the diagonal elements of A. Diagonal elements say 1 5 3. I want to create a diagonal identity matrix with the identity matrix of dimension 3 cross 3. Diag 1, okay, or diag 3, diag 7, diag 9. The number to be repeated in the diagonal elements and dimension of it. Okay, fine. Okay, right. Now that is a determinant function that results here like this. Now here this line is quite very trivial to understand, that I'm taking always in a matrix, when you represent a matrix A of square brackets, the argument left side to the comma corresponds to row. Argument right side to the comma corresponds to column. Now, what I am defining here, I am taking second row of A. Second row of A, 459. I am multiplying with a scalar value 2 into A of 2 comma this thing. Means I am taking all the columns into account. Okay, and then multiplying the second row alone with the 2. Now, resultant matrix is this. 127 remains same, 683 remains same, but only the operation happened only with the second row, that is 4, 10, 18. Or suppose I want to multiply only the third column. What should we do? We should take A comma 3 is equal to 4 into any number, 4 into A comma 3. Now, the third column will get multiplied, results to 1, 2, 7 into 4, 28, 4, 5, 36, 6, 8, 12. Like this. Whatever, if you want to do any element, let us do like this. A 2 comma 3. A 2 comma 3 is what? A 2 comma 3 is 9. I want to multiply 9 with only 2. I can do that. A 2 comma 3 is equal to 2 into A 2 comma 3. So only 9 will get multiplied with 2 and results with 1 to 7, 4, 5, 18, 6, 8, 3. So like this, you can have a fun with operating different cells, columns, rows, and multiply each row. So you have a better exercises and have a proper grip on operating different cells of a matrix, either with a row or column. Okay, now in matrix operation, we might have used or we use majorly to have eigenvalues and eigenvectors. So a simple function to obtain the eigenvalues is eigen of A. That's it. It is done. Okay, so fine. Now what I do is I stop here because the understanding data is taken into the afternoon session. Okay, understanding data is taken to the afternoon session. We stop here with the basics of R and how to do with the vectors, matrices, how to do with cells and references of the matrices, all these things. So I repeat again, this is very basic introduction, keeping in mind with the graduate students. Okay, right. Now I leave the platform to the participants or organizers if you have any questions here. Okay, so that we can take it into the further sections to have it in a proper way also. I encourage suggestions also. Is this what kind of orientation is fine? And in later sessions, we'll do live. We'll do live because these are all very small things. These are all very small things. I did it in our console and screenshot is this thing. Okay, fine. Now in later sessions, tomorrow, day after tomorrow, something and so on and so forth, we go with live usage of R and R Studio. Okay, right? Fine. There are wait. There are many questions are there. Many questions are turning up. Many questions are turning up. Quite a good questions or messages are turning up. Let me see that. Okay, there are some questions like once again about last example of sequence. Okay, fine. What about the last example of sequence where we were? See the sequence of, you were talking about sequence of 2, 3, 4, 5. The question is raised by Yoga Sri Lakshmi. Okay. The thing is, I am defining a vector, a series of values in a vector, C, 2, 3, 5, indicating that 2 means repeat first 2 values, 1, 2. 3, repeat first 3 values. 5, repeat 1, 2, 3, 4, 5. That is the thing. Okay. And next question comes here. Or GL and repeat same. Okay, a repetition is different, GL is different in the sense that in the sense that repetition is used to repeat what do we say, a sequence of values which are required multiple of times. But generating levels will help us to have a proper data frame network. Okay, it will help us to create a proper data frame network. That's why GL is better, and most of the statistical methods like design of experiments, it will GL function will help us defining the data in terms of one-way ANOVA, two-way ANOVA, and so on and so forth. Right? Okay. Next. Okay. Allah, thank you. Do we have afternoon? Yes, we have. We have afternoon session every day. Every day we have two sessions, morning 10:30 to 11:30, afternoon 3 to 4. Okay. Accordingly, we have planned, and without having more dump on you, and then we will cover the contents. I will cover the contents. So I have a doubt in sequence C, comma 2, comma 3. This is very, just now I repeated, explained it. First 2 stands for 1 and 2. Repeat the sequence. 2 means limit to only 1 and 2. Next 3, it is 1, 2, 3. It will create a sequence of first to 3 numbers. Let us take sequence of C, comma 2, comma 10. What will happen? 2 is the first instruction. So it will repeat 1 and 2. Next instruction is 3, 1, 2, 3. Next instruction is 10. It will repeat, it will create a sequence of 1 to 10. Okay, that is what we get. Okay, that is Corona on statistics is nothing but, there's a question is, can you please repeat what you told about Corona on statistics? So the thing is, I think I might have used it in this, that how about the shares, images, videos, okay, some kind of a messages which we are getting to be safe on our own with the Corona, that how many likes, how many comments, how many shares, all these things is a statistical data now. I have used one particular what do we say, concept, topic, Corona. In 2016 or in any year, let us take a topic on Amphan, which recently hit West Bengal and Northeast, upper part of Andhra Pradesh, that we can talk many things. Okay, likewise, basing on the topic, data gets generated. Okay, I used Corona only for this. Okay, someone is asking, can you send the R file? These are all very, very basic things. Anyway, we'll try to share it once everything is done. May I know the difference between sequence and sequence? Sequence is, see, what we have done here is, in sequence is 1 to 10. I mean, in SEQ, we'll have a starting range, ending range, or we may have the control on the ending range with length argument. Okay, in sequence, in CSE, complete sequence, there is, we can generate multiples of string, what we say, values with what is the length we are defining directly. The number 2, 3, 5 in sequence, complete sequence function, is the length that what the sequence should be. By default, it will start with 1. Okay. Okay. Thank you. We are telling. Yes, we can solve any dimension of a matrix using solve. Okay. Say there is telling that sequence of 1, 2, 2, 2, 2, 3. Not sure, sir. Okay, 1 may not come. I doubt. Okay. Matrix multiplication is simple. You have a matrix A. When you want to multiply two scalars, just you have to use 8 into 3 or 5 into 7 into asterisk alone. But you want to multiply when you want to multiply this matrix, two matrices, then what you have to do? You have to use A percentage asterisk percentage B. So that percentage asterisk percentage will enable the matrix multiplication. Okay. Now there is one more question. That's good. You are raising good questions. I like this. What is the difference between n row and by rows? N rows is nothing but how many rows you want to have in the matrix. By row is to arrange the cell values, arrange the matrix values. How you want to arrange? By default, it will be by column. Okay, by default, when you use, we have used that matrix of C of elements of a matrix, comma n rows is equal to 3. The default argument is by columns. But you want to have the matrix value, elements of the matrix in row wise, you have to add an additional argument called by row. Okay, that is the difference. Why we must use C everywhere? Because you are defining a set of elements to a one variable. Okay, to define a set of elements to one variable, assigning variable, we need to use C. Okay, when we work with data set, that is different scenario that we'll see next classes. Okay, clarify timings: morning 10:30 to 11:30, afternoon 3 to 4. What is the argument? Okay, what is the argument of the value 20? 28 is meant how many rows we have to generate. Okay, that should be properly calculated based on the number of levels you want and number of times each level should be repeated. I don't think so. In INV function is not available. To my best of my knowledge, INV is not available in R. Solve only is the thing. Okay, right. As of now, I won't entertain you to install RStudio. Okay, demonstrations will be given. I think in the case study, by the end of the 4th day or 5th day, you will be equipped with some abundant practice, knowledge, how to do all these things. Then in the 6th day, the case study day, we will give you, first I will show you how to do one case study. Then we have planned to share some data sets to you, and thereafter you can do, and you can, if you have any issue, you can share the screen to me or my team, then they can see and rectify your problem. Okay. Diagonal 1 comma 3 comma 3 is nothing but repeat 1 with the dimension of 3 comma 3. That is 1 0 0 0 1 0 0 0 1. Okay. Yes, I'll tell the instructions to share the video so that they can have participants can have even thing. Okay, we can have practice. Okay, there is one small, very simple question that A2 comma is equal to 2 into A comma. That is nothing but multiplying a particular row or a column. A2 comma and 2 into A2 comma is nothing but it is used for elementary operation within a matrix. Elementary operation within a matrix can be done using this. Okay, 1 minute. Sorry, to everyone, you can write to me if you have doubts in the sequence of these sessions. I'll try to take it during the non-session time and then try to address during the program. Okay, this is my email ID. You can write to this email ID if you have any questions. We'll meet you around 2:45 this afternoon. Thank you.